Hi, our next topic is circular convolution using matrix multiplication method. This is one of the method to find the circular convolution. Okay, let us go through a problem. This is the question given. Find the circular convolution of two discrete time signals x1 of n is equal to 1 to 2 1 and that of second signal x2 of n is equal to 1 2 3 1. Okay, let us solve the question. Before that, I'm going to write the given signal once again. Okay, x1 of n is 1 to 2 1 and what about this element that is x1 of 0? This is x1 of 0 and of course this is x1 of 1, this is x1 of 2 and finally this is x1 of 3. Number of elements in the first signal is 4, starting from x1 of 0, x1 of 1, x1 of 2 and x1 of 3. What is the length of this signal? Length is equal to number of elements. Total number of elements in this signal is 4. Therefore, we can say that the length of the sequence is 4. Similarly, we can write the second signal also. Okay. This is x2 of 0. This one is x2 of 1. This is x2 of 2. And finally, this is x2 of 3. Okay. And the length of the sequence is equal to 4 itself. In order to, as we know, in order to perform a circular convolution, both signals must be of the same length. Means length of x1 of n and length of x2 of n should be equal. Here that condition is satisfied as this length of first signal is equal to 4 and that of second signal is also 4. So we don't need to do anymore. Okay. The next thing we have to do is represent the second signal x2 of n in n by n matrix where n is equal to 4, that is the length of the sequence. Next, what we have to do is represent the second signal x2 of n, okay, in n by n matrix where n is the length of the sequence, and represent the x1 of n in the form of column matrix. Okay. That is now we are going to represent x2 of n in 4 by 4 matrix form and x1 of n in column matrix with n equal to 4 elements. Okay, let us go through that. We have to express, first of all, we have to express second signal in 4 by 4 matrix. Okay, then I'm going to construct a matrix in which there should be 4 by 4 in the sense number of rows are 4 and number of columns equal to 4 itself. Okay, this matrix can be considered as a square matrix as both rows and columns are equal. Okay. Now, in order for that, I'm going to, this matrix is constructed in a particular manner. So let us do that. X2 in 4 by matrix. Then you have to write x2 of 0, then x2 of 1, x2 of 2, and finally x2 of 3. Then all elements are here, starting from x2 of 0 up to x2 of 3. Only 4 elements. Therefore, number of rows are 4. 1, 2, 3, and 4. Now, listen carefully. Now I am going to write the second column. For that purpose, we have to shift the last element, that means x2 of 3, upward. Then there should be corresponding shift in the downward direction. What I mean is, in the next column, the first element should be the last element, means x2 of 3 should come first. Here I'm going to write this one, x2 of 3. Then proceed as in the same way. The next element should be, of course, this one, x2 of 0. Then the next element should be this one, x2 of 1. Give a downward shift, okay, right? Then obviously the next element should be this one, x2 of 2. Okay, now all elements are arranged in the second column. Now let us construct the third column. Of course, that should be the last element. I mean, the x2 of 2 should come first. Okay, x2 of 2, then this element. Okay, x2 of 3, the next element should be this one, x2 of 0, and last one, this one, x2 of 1. Okay, right. Next, in order to obtain 4 by 4 matrix, as n equal to 4 by 4 matrix, we have to construct one more column. Okay, right. Now we have 4 rows. So far we have only 3 columns. The next column can be constructed as in the same manner. That is, x2 of 1, the last element, should come first. x2 of 1, then the next element should be, of course, this one, x2 of 2, then x2 of 3, and finally x2 of 0. Okay, the first sentence represent x2 of n in 4 by 4 matrix form is over now. Okay, this is 4 by 4 matrix, 4 elements and 4 columns. Now together with, we have to arrange x1 of n in a column matrix form, that is written over here. Okay, now I'm going to represent this x1 of n in column matrix form, like x1 of 0, x1 of 1, x1 of 2, x1 of 3. That should be equal to the circular convolution output y of 0, y of 1, y of 2, and finally y of 3. Okay, right. Means the circular convolution between x2 of n and x1 of n should be equal to y of n. That is our concept. Now everything is over. Just we have to put the values of x1 of 0, x1 of 1, x1 of 2, and so and so into this matrix. That's all. Okay, let us do that. I'm going to put the values of these elements. Okay, at first we have to enter the value of x2 of 0. x2 of 0 is 1, x2 of 1 is 2, and x2 of 2 is 3, and finally x2 of 3, that is equal to 1. Okay, now complete the entire elements in this square matrix. Now I completed the second column. Now we have to complete the third column and fourth column. Okay, right? 3, 1, 1, 2. Then this 2 should come first. 2, then 3, 1, this 1. Okay. Now x2 signal is over. The square matrix over. Next we have to construct the column matrix x1 of n is 1, 2, 2, 1, 1, 2, 2, 1 in downward there. Okay, 1, 2, 2, 1. Sorry, 1, 2, 2, 1. That should be equal to our result y of 0, y of 1, y of 2, and y of 3. Now just what we have to do is just multiply by using ordinary matrix multiplication method. Okay, then the result will be the circular convolution using matrix multiplication method. Let us do that. Okay, 1 into 1, that is equal to 1 into 1 plus this 1 into 2, 1 into 2 plus 3 into 2, 3 into 2 plus this 2 into 1, 2 into 1. Okay, next this 2 into 1, 2 into 1 plus this 1 into 2, 1 into 2 plus this 1 into 2, 1 into 2 plus 3 into 1, 3 into 1. Okay, that's over. Next, this 3 into 1, 3 into 1 plus this 2 into 2, 2 into 2 plus this 1 into 2, 1 into 2 plus 1 into 1, 1 into 1. Okay, last, we have to multiply 1 into 1, 1 into 1 plus 3 into 2, 3 into 2 plus 2 into 2, 2 into 2 plus 1 into 1, into 1. That will be the required result y of 0, y of 1, y of 2, and y of 3. Okay, now let us solve this 1 into 1 plus 1 into 2 plus, what about this one, 1 into 1, 1 plus 2 plus 6 plus 2 gives 8. Now let us multiply this value in order to obtain y of 0, y of 1, y of 2, and y of 3. 1 into 1 gives 1, then plus 1 into 2 is equal to 2, plus 3 into 2 gives 6, and finally 2 into 1 gives 2. Now multiply and add the elements in the second row. 2 into 1, 2 plus 1 into 2, 2 plus 1 into 2 again, that is equal to 2, and 3 into 1 gives 3. Now proceed as in the same way. Then we are getting 3 plus 4 plus 2 plus 1, and for the last row we are getting 1 plus 3 into 2 gives 6 plus 4 plus 1. That should be our y of n. That means y of 0, y of 1, y of 2, and y of 3, that is obtained as in column matrix. Okay, now add these elements and obtain the column matrix in the left hand side. Okay, now we are getting the values like this: 11, 9, 10, 12. Okay, that means y of 0 is equal to 11, y of 1 is equal to 9, y of 2 is equal to 10, and y of 3 is equal to 10. Since both LHS and RHS represents a column matrix, the element in the left hand side will be equal to corresponding element in the right hand side, as these are column matrices. Okay, that means, that implies that y of 0, equal to corresponding element, first element 11, y of 1 is equal to corresponding element in the left hand side column matrix, that is equal to 9. Then y of 2, that is equal to 10, and finally y of 3 is equal to 12. Y of 3 is equal to 12. Now we know that the convoluted output to y of n is equal to y of 0, comma, y of 1, comma, y of 2, comma, y of 3. So let us write the corresponding values: 11, 9, 10, 10 comma 12. That will be the required result. Okay, thank you.